Assalamualaikum. We are from the ANC Engineering Sdn Bhd. So, for our project, we'll be doing a cadangan mendirikan 16 unit rumah berkembar 3 tingkat jenis RB3AA di atas sebahagian lot 12025 Mukim 12 BBD di Persiaran Kelicap, Pulau Pinang. This project will be presented by Ifa Amalia, Tuan Muhammad Fariza, Siti Aisyah, Maizatul Izlin, and Arliana Natasha. For our company, ANC Engineering, the vision would be ANC continues to move forward in becoming the leading multidiscipline engineering company, providing project engineering, project management, engineering studies, construction, and maintenance work in Malaysia. ANC Engineering mission would be to strive, provide high quality and efficient service in engineering to the clients to allow them in achieving their goals. This is the picture of the ANC logo. So for the ANC Engineering Sdn Bhd, the company will be located at number 825 Lorong Pau 2/2 Taman Pau Indah, Permatan Pau, Penang. This location is strategic as located nearby Batu Kawan Industrial Park and also Kulim High Tech Park. This shows the organization chart for our project. Ifa Amalia will be handling the road and drainage. I myself, Arliana Natasha, will be handling the structural engineering, whereas Siti Aisha will be handling the geotechnical, and Maizatul Izli will be handling sewerage, whereas Tuan Muhammad Fariza will be handling the water reticulation. Next, I'll be presenting to you on the project description. The project location will be located at lot 9001 till 9016, Mukim 12, Daerah Barat Daya di Persiaran Kelicap, Pulau Pinang. And the existing nearby facility would be an international school, mosque or church, international airport, health facilities, and also an army base camp. The picture below shows a picture of the location of the project. So for the project detail, the district will be Barat Daya Pulau Pinang. Local authority will be Majlis Bandaraya Pulau Pinang MBPP. The site location would be Persiaran Kelicap, Barat Daya Pulau Pinang, and the coordinate will be 5 degree, 18 minute 20 second north and 100 degree, 15 minute 34 second east. And the area will be 606,300 meters square. Next, I'll be explaining to you the project authorities, the agency and organization and their responsibility. So for Public Work Department, also known as PWD, their responsibility will be to monitor the project operation and the requirements that the developers and the contractor must meet with regard to environmental compliances. So for the Urban Development Authority would be observing the terms outlined in the letter of authorization. Next is the Road Development Authority. Their responsibility is to observe the terms outlined in the letters of authorization. Next is the citizen, local community and sectors is to inform the public of any environmental issues that might arise as a result of the project. Next is the police department. Their responsibility is to safeguard and securing the project's material resources. And lastly is the fire service department. Their responsibility is to provide the necessary protection and fire prevention measures. Assalamualaikum. My name is Arliana Natasha. I would be the structural engineer for this project. So I am going to explain to you on the structural design. For the design methodology, first you need to have the architectural drawing. Next, from the architectural drawing, you need to provide a structural key plan drawing, and then you need to do a design element calculation from manual and esteem, and both of the calculation is then compared. The table shows the design consideration for both esteem and manual. So for the unit weight for esteem would be 25, same goes with the manual, and the concrete cover for both esteem and manual is different. Esteem would be 25 and manual would be 30. The FCK for both esteem and manual is same, which is the value 30, and the FYK value is 460 for both esteem and manual. The drawing shown the architectural drawing for the ground floor, first floor, second floor, and also the roof floor of the building. The drawing shows the architectural drawing for the front view and the side view and the cross-section view of the drawing for the proposed project. The picture shows the structural key plan of the project. So how is it made is from the architectural drawing is then export to the Esteem software, and later will be drawn the grid line and will be placed all the elements such as column, beam, and slab. This drawing must be the same as the architectural drawing. The picture shows the structure key plan for the second floor and roof floor. This shows the structure key plan for the roof floor. The picture shows the structural 3D view of the project, which is a bungalow. This picture is gotten from the Esteem software after designing all the elements. The load transfer flow is first from the ground slab to the beam, then the load to the column, then lastly to the foundation. This is also from the highest floor till the ground floor. So for the slab design procedure, it is shown on this flow chart. So first you need to have the preliminary thickness of slab. Second, the nominal cover, C known. Then you need to find the design action. Fourth is shear and moment coefficient method. Fifth is shear force and bending moment. Sixth, you have to design the reinforcement. Seven, design shear reinforcement. 8, design check, and then cracking check, and lastly the detail. The flow chart shows the beam design procedure. So first you need to find the preliminary size of slab, then the nominal cover, C norm, later the design action, then you need to calculate the moment distribution method, MDF, next shear force and bending moment, and then you need to find the design reinforcement and design shear reinforcement. Then you need to check on the deflection and cracking, and lastly the detailing. So for designing the column, first you need to find the preliminary size of column. Second, the load transfer on column. Later you need to do the ultimate axial load and slenderness check, and then the nominal cover, then the design moment, design reinforcement, then you need to do the design link, and lastly the detailing. The design procedure for pad footing is first you need to determine the size of foundation, then determine the load capacity, and determine the axial load and the design reinforcement. Later check for the deflection and cracking, and lastly, do the detailing. So for the design comparison for both esteemed and manual calculation is shown on the table. So for the slab and beam, there is no percentage differences, whereas for column, there is a percentage differences more than 50. This might be because of the increasing amount of calculation needed when calculating using manual calculation, and there might be some error while calculating. This slide shows a picture of the slab detailing on the ground floor for the top and bottom detailing. The picture above shows the example of the beam detailing of the project from the first floor, showing three beam detailing. This detailing is gotten from the Esteem software. The above table shows the column detailing from the Esteem software. So this is the all the detailing for the column.
Hi, Assalamualaikum warahmatullahi wabarakatuh and greets to our panel. So I am Siti Aisyah binti Ahmad Subari and I will present the infrastructure work in earthwork design. So earthwork is basically involve moving, forming, cutting or filling earth on the project site. And then it must be completed at the preliminary stage of the construction phase. So earthwork is critical because if it completed on time, the construction will not be delayed and can be continued with other activities. So the objective here is to improve the soil condition on site so that it can sustain the structures that will be built, and then to estimate and determine the precise earthwork needed for the project's practicality. And lastly here is to aid in land use planning and compliance with applicable guidelines and rules. So this is our earthwork layout. We have proposed a few important things on site such as earth drain, sediment pond, detention pond, washroom and the proposed level of the site and few other things. So here is the scope of the earthwork. As for the survey work, we have to do the horizontal and vertical survey to determine the existing ground level. Next, the site clearing. It is a process of removing all elements of the land area that obstruct the process of construction. And then the surface setting out. The site demarcation and benchmark need to be approved by the qualified land surveyor. And therefore, the temporary works, some infrastructure will be constructed as part of earthwork, just like I mentioned just now. And lastly, we have cut and fill. I will explain on detail for cut and fill work here. So this is the common method used for any construction project, and the cut and fill is the process of mass addition and mass removal of soil. So there are a few other methods in determining the cut and fill area on site, and this project used the grid method. So the accuracy of the calculation is depend on the grid cell size, and this project used the size of 25 times 25 meter square for the grid system. So here is the earthwork grid method where we implement on our project site. This consists of 19 8 grid box. So here is our cut and fill calculation where we include in a software. After we propose a new level on site, we just include all the numbers inside this software to obtain the area that needs to be cut or filled. And then the summary of cut and fill is as shown here. The total volume of access cut on our project site is 320,267.90 meter cube. So the primary purpose of the sediment basin is to prevent sediment from entering stream, river, lakes, or wetland, or existing drainage. By doing this, it will collect and detain the runoff, allowing the suspended solid to settle down prior to the runoff leaving a site. And then the size of the sediment basin is determined by its location, drainage area, size, soil properties, land cover, rainfall intensity, site condition, and few more others. So it is a temporary barrier estimated to last 12 to 18 months and must be managed to keep up until the site area is secured from erosion. So we need to know the category of the soil condition, and based on the MASMAS specification for our site, it is sandy loam type which have the hydrological soil group A. So the basin type here is dry, and the design consideration is settling velocity and sediment storage. So here is the sediment basin that we have proposed on site. It is located at the lowest point of the site, so the water retained on the earth drain can flow with gravity into the sediment pond. This is the software we use in determining the size of sediment basin. The software followed MASMA standard, and we just have to include the values from the site. Then it will generate a size of sediment basin that is suitable for the site. So we will have to include our project area here and the point where the earth drain start and end. From the value above, this is the overall dimension that generated from the software. As you can see here is the sizing of the basin outlet and the sizing of spillway. So the type of orifice is submerged and square edge. So here is the sediment basin dimension. It is as generated from the software. The length is 204 meter and the width is 30.4 meter. With settling zone depth 0.9 meter, and the slope with the ratio 2 to 1.
Assalamualaikum and salam sejahtera. My name is Sifa Amalia and I will be the road and drainage engineer for this project. So the concept and design of road at lot 9001 to 9016 Mukim 12 Bayan Lepas Pulau Pinang will be discussed in this slide. The objective of road design for this project is to design a roads according to their performance requirement, and the second objective is to provide regular, safe and dependable road, especially for kids and oldster. And then the concept of road design is land context, which accommodate the needs of individual places and neighborhood. And the second concept is safety, which we will highlight on children and oldster. And the last concept is efficiency, to provide appropriate space to sustain capacity of development in the project. So the data required for this road design is, the first one is type and volume of the area, and then subgrade type and strength, and the last one is type and properties of paving materials used. So this is the design standard and design speed that I refer to design our road for this project. So as we can see from table below, the category for the road is R2 because the initial daily traffic volume is 1000 and the road category is minor road for rural area. So based on the category of R2, we can identify the design speed based on the next table, which is design speed table for rural area. And the terrain of our project is mountainous, which means the design speed for this road is 40 km per hour. Okay, next is drainage design. Stormwater management (SWM) is a control mechanism of stormwater runoff. The recommended drainage system design for the development will be presented in this slide. The objective of this drainage design is to provide specification for drainage system and to design collector drain system for this project. To design the drainage system, we need to find the overland flow time, which consists of Horton roughness, overland flow length, and slope overland surface. Based on the table below, uh, it shows the value of Horton roughness based on the land surface of the project. And then we need to find the drain flow time, which consists of Manning's roughness, length of drain, slope, and radius. And the table beside shows the value of Manning roughness based on the drain and pipe used for the project. Okay, this is the road and drainage layout plan for this project. The left side shows the layout of road and drainage, which the brown color represents the road and the blue one is the drainage system. Then, the right figure shows the detail of the drainage for section AA. The type of the drainage was designed with round bottom. Okay, this is the calculation of the drainage for line D. The specification of the proposed design have been presented in the design sheet, which is the width of the drainage is 0.27 meter, the depth is 0.45 meter, and the diameter of the round bottom is 0.13 meter. All value needed are shown in the design sheet, such as overland flow time, drain flow time, velocity in drain, and the time concentration. Besides, the rainfall intensity also can be calculated and the peak flow for the drain is identified. To conclude this design, the proposed dimensions of the drainage can be used for this project. Okay, the next slide will show the overall drainage design value. The overall value from line A to line I for the drainage design of this project are shown as figure attached in this slide. Next is detention pond. Detention pond is the most significant component for stormwater quantity control. There are two objectives of the detention pond design, which is to provide specification sizing for detention pond and to release runoff at certain rate to prevent flood from occur. The area of development is 60.63 hectare, which is quite large, and the size proposed must be suitable for the area. The volume for each ARI for post-development are shown in the table above. Based on the required pond volume, the size is provided as the left table. This is the layout plan for the detention pond of our project with its dimension. This slide shows the calculation sheet for the proposed detention pond. Based on the nearest station, which is kolam takungan air hitam, the IDF empirical equation can be determined. The overland and drainage channel flow time for pre-development and post-development can be seen in the calculation sheet. The volume of detention pond provided is more than the required pond, so the size provided is pass for this project. Next, the sizing of outlet pipe and the spillway also pass for this project. That's all for road and drainage design.
Assalamualaikum warahmatullahi wabarakatuh. I am Maizatul Izzi binti Ali as sewerage engineer for this project, and I'm going to present about sewerage design. Design criteria of gravity sewerage. The sewerage system should be suitable, designed to carry all wastewater flows including sludge to sewage treatment plant (STP). All sewer and manhole shall be sited in public land where access can be gained for maintenance purpose. The normal minimum depth of sewer to invert should be 1.2 meter. The volume of sewage that needs to be treated per day is based on an assumed contributions per person of 2 to 5 liters per head per day. The minimum design velocity at full flow should be 0.8 meter per second to allow for self-cleansing. The maximum design velocity at peak flow should not be more than 4.0 meter per second to prevent sedimentation. Next, the minimum depth of soil cover over the sewer should be 1.2 meter. The minimum size of gravity sewer should be 2 to 5 mm in diameter. The minimum size of domestic connections to the public sewer should be 150 mm in diameter. Manhole location should be at starting end of all gravity sewer. Every changes in direction or alignment for sewer less than 600 mm in diameter. Every changes in gradient, every junction of two or more sewer, and every change in size of a sewer. Sewer works should be tested and inspected for water tightness to prevent infiltration to ensure pipes are laid correctly. Design parameter of this gravity sewerage. For all manhole, the depth should be 1.2 meter, while the velocity is minimum of 0.6 meter per second and maximum of 4 meter per second. The bed drop of manhole should be 900 mm for pipe less than 2 to 5 meter. The calculated population equivalent are 365 as we consider 5 PE per house. By this, the land area required by calculated of PE is 600 meters square. The design of sewerage system should generally be accordance with the principle in the Malaysian Standard MS 1228 Code of Practice for Design and Installation of Sewerage System and in conjunction with other design guidelines such as SPAN 3rd edition and SPAN Technical Specification. This is sewerage layout plan that consists two connections which are from manhole number 1 to number 17 that connect the sewerage line of A to B and manhole 18 to 23 that connects the sewerage line of R until U. This is the hydraulic design calculation example for manhole number 5 to manhole number 6 for sewerage line E. The design computations are type of pipe used in this project are VCP. The coefficients are 0.017, diameter of pipe 2 to 5 mm, area of pipe 0.04 meter square, perimeter of pipe 0.707 meter, weighted perimeter calculated is 0.057 meter and the gradient is 1 to 200. For this project, many equation was used to get the velocity. Velocity by using many equations are weighted perimeter power of 2 over 3 times with gradient power of half divided by the meaning coefficient. By substituting the formula, the weighted perimeter calculated is 0.057 power of 2 over 3 times with the gradient 0.005 power of half divided by 0.017 for the meaning equation. Thus, the calculated velocity for line E is 0.611 meter per second. These calculated velocity are within the range of required velocity of minimum 0.6 meter per second and maximum 4 meter per second. In addition, the peak flow for this line E is 1.577 liter per second, less than the full pipe flow 24.279 liter per second, which means for this pipe, it is following the required. This table shows the summary of hydraulic design calculation for sewerage line in this project. As we can see, all the sewerage lines calculated velocity are within the range of minimum 0.6 meter per second and maximum velocity of 4 meter per second. In addition, the peak flow is lower than the full pipe flow. Therefore, we can say all the sewerage lines in this project are acceptable.
Assalamualaikum. For the next part, I, Tuan Muhammad Farizal, will present to you about the water supply design for this project. There were four objectives of the water supply design. The first objective is to identify the size of the pipe and the form of the internal plumbing. The next one is to calculate the peak demand for water that flows in the pipe. The third objective is to find the location of air valve, sluice, score valve, and also fire hydrant. The last objective is to decide the location of the water distribution pipeline for the whole area of the project. The design guideline that has been used for this water supply design is Uniform Technical Guidelines Water Reticulation and Plumbing by SPAN, Fire Flow Requirement Table 14.18 by Malaysian JKR Standard, and JKR Design Criteria and Standard for Water Supply System. For the water supply design, there were a few restrictions based on the guideline. The first restriction is the pipeline must convey peak flow in external reticulation networks at 2.5 times the average daily demand flow, and therefore the supply means, which is 1.2 times the average daily demand flow. The pipeline also have to convey a combination of average and fire flow without incurring head loss of greater than 15 meters per ton per 1,000 meter. And the next one is the pipeline must convey flow with a velocity of not less than 0.3 meter per second in order to reduce the deposition of the sediment. The next restriction is the pipeline must have a maximum flow velocity not exceed 2.0 meter per second. And the minimum pipe size in an external reticulation network system shall be 100 mm. And the discharge residual pressure at the highest supply level, HSL, shall not be lower than 7.5 meter. There were also a few requirements that has been set by the local authorities, such as the first one is JKR, which give a requirement for the specification of applicable codes and standards for joints, pillar hydrant, and other piping use. JPA Pulau Pinang, where we need to do a submission report of the request of pressure head available at the proposed stepping off point and existing water pipe. And for the PBAPP, we must have approval for water supply connection from existing water supply. And for the bomber, we have to consult and approval with respect to fire flow requirement and number, location, and type of fire hydrant to be installed. And last, for the MBPP, we have to do the submission report of application for approval to start the construction. As you can see now, this is the diagram of the proposed external water reticulation system for our project. And this is the distribution drawing for the domestic and also for the fire hydrant for the outlet. Based on the calculation, the total demand for the domestic pipeline of our project is 122,000 litres per day. For fire flow, the total water demand for two hydrants is 136,800 litres per hour. For the calculation of residual head for our pipeline system, the pipeline system will be divided into three models, which is model 1 for tapping point to the suction tank, model 2 which is for from the elevated water tank of domestic water supply to the individual unit, and for the schematic for the model 3 which is from elevated water tank of for fire flow to the highest elevation of hydrant. At the end of the calculation, we will get the residual head above supply level, which is the value must be greater than 7.5, and we will be designing our pipeline system